Well, hello everybody. Welcome back to the Educator. So today, uh, I would welcome you to the chemistry section of the Educator. I'm Roshan Samarikrama again, and today we are going to discuss about the cooling curve. So let's start off. Our contents for today's program would include of getting to know what the cooling curve is, and secondly, what we can see in the cooling curve, and also identification and analyzing the cooling curve for the solidification of a pure metal. So first of all, moving on to our first topic. What is a cooling curve? Providing an answer to this question, I would like to say a cooling curve is a change in the temperature with time for a material over entire temperature range through which it cools. So a cooling curve is a graphical plot of the changes in temperature with time for a material over the entire temperature range through which it cools. The cooling curve for pure metal will be discussed in the latter section of this presentation, and this by far is the most widely used experimental method. It relies on the information obtained from the cooling process. So it explains that we form the cooling curve from the information that we obtain from the cooling process experiment. In this method, alloys with different compositions are melted and then the temperature of the mixture is measured at a certain time interval while cooling back to room temperature. A cooling curve for each mixture is constructed and the initial and the final phase change temperatures are determined. Then these temperatures are used for the construction of the phase change diagrams. Phase change diagrams will be explained in another video from our channel. And we could now, as we all know, the introduction to what is a cooling curve, we could move on to the next section of our presentation. Okay, this also gives another part of the definition. A cooling curve for each mixture is constructed and the initial and the final phase change of the temperatures are determined, as I explained earlier, and these are used for the construction of the phase diagrams. I told you we'll explain the phase diagrams in another video on our YouTube channel. Moving on with the presentation, our next topic, what can we see in the cooling curve? So, could you guess what we could see in the cooling curve? Well, if you don't have an idea about the cooling curve now, you might doubt about it. But if you have a clear idea of what the cooling curve is by now, if you have studied it at school or you've researched on it, then you might know by far what the cooling curve is and what we can see in the cooling curve. For those who want to revise and for those who don't know, you can see a cooling curve here on the left hand side on the upper section. If I would show you, over here, you can see the temperature. You could see the temperature here, mentioned T, and then here again time, this is mentioned in capital T and this is in simple T. So this is temperature and time. So temperature and time are the two factors that we consider while constructing a cooling curve. So here you could see the cooling curve starts at a point where it is mentioned superheat from that point to a point below. So the cooling curve starts from here and it moves on, meaning that it cools down. And then here, the cooling curve goes into a constant period of, for a constant period of time on the same temperature after decreasing from a higher temperature to a lower temperature. It goes on a constant temperature until this point of time, and then it cools down, it reduces its temperature again to this point of temperature during this time. Moving on, the cooling curve for the solidification of a pure metal. If you could remember the contents, I told you we will be analyzing about a cooling curve for the solidification of pure metal. So now we are going to do that. Moving on with that, there's a few notes for this. Under the equilibrium conditions, all metals exhibit a definite melting or freezing point. Full stop. A cooling curve for a pure metal. It will show a horizontal line at the melting or the freezing temperature. If you could remember, here there's a horizontal line, which is a horizontal line after the temperature decreasing from superheat to an amount of temperature over a certain period of time where the local solidification time starts. There's a horizontal line that, according to this, is the melting or the freezing point of that metal. If you take this for this as the cooling curve of a metal, then this horizontal line that is showed is the melting or the freezing point of this pure metal. Moving on, here the same thing you can see again, the same cooling curve. It shows a horizontal line at the, if I show you more clearly, it shows a horizontal line here. It cools down from superheat to up to this temperature point during this period of time. And then there you can see a horizontal line. This we call the equilibrium, or is a fixed melting or freezing point for a particular metal. And then after this point, it further goes down with the temperature, where it goes to solidification, we can say. Here it's in the gas state, it condenses to the liquid state. This is the melting or the freezing point, and then it goes down more to become a solid, reducing its temperature. So you can clearly understand how what the horizontal line is there for. And then I explained about the cooling curve and how the cooling curve is plotted and what the phase changes in a cooling curve are. So that with this, we come to the end of our video for the cooling curve. I hope I have explained the cooling curve clearly so that every one of you could understand. And hope to see you in another video, another science video or another subject video from our YouTube channel. If you haven't yet subscribed to our YouTube channel, The Educator, you can just go to our site, to our YouTube right now, and then click on the subscribe button. And if you want, you could push on the notification so that you will get updated with all the videos that we post. Thank you, and may God bless you.